Hello there, welcome to the Learning of Engineering Tutorials video lectures. In this video lecture, we are trying to learn what are the longitudinal stress existed in a thin cylindrical vessels. We know these vessels are widely using for the storage of the fluid under certain the pressure conditions we are using. That's the storage containers that's maybe at the stationary conditions like petrol bunks, or some are using for the containers for these pressure vessels in the transportation purpose of the oil, water, milk, or maybe the oxygen or the nitrogens, whatever it may be. So then what will happen here? So we are storing the fluid under certain pressure. It means that it will create a pressure, that means the pressure force on the walls of the cylinder. And we have seen in the last class that pressures are the pressure forces are going to be developing in this way. Suppose I have taken this is the pressure vessel of this cross section, and we can see inside there is the fluid is going to be there, assume. So then what happened? It's going to be creating a pressure on the walls. So that is going to be acting along the longitudinal axis, along the cross sectional. That means in the that means the circumferential direction. So these loads are going to be acting, and then what happened? The failure will going to be occur in the longitudinal direction. That we are going to say the circumferential stress or the hoop stresses we have calculated. In this today class, we will see when there is only the load is going to be acting in the longitudinal direction. We are assuming that there is the load is in the circumferential direction. So that I am going to be removing over here. So then we can see this member is going to be subjected to the longitudinal directions, that load. So then what will happen? This member is going to be trying to move in the longitudinal direction. Then the failure will occur along the circumference of this member. So that cross section I had given over here, can you see? This is going to be the failure of the component. These are the expected failure is going to be occurred. So then what happened here? That's going to be sigma 2. So can you see here? That's the load is going to be coming and the resistance forces are going to be developing. Finally it will going to be failed. We know that the diameter of this the pressure vessel is going to be the D. At the same time, the thickness it has. So now by using these geometrical parameters, we are trying to develop the longitudinal stress which are acting in this member. Can you see? The load is acting in the longitudinal direction, but the failure is occur in the circumferential direction. Then according to the load direction, I can say this is going to be the longitudinal stress. So now I am going to be taking here, can you see? The pressure is going to be acting. So from this one, the pressure P is going to be acting in this case. That's going to be the pressure force by area I am going to be considering. So now can you tell me what is the area the pressure is going to be subjecting? As we know that this is going to be the area that is going to be subjecting. That means internal diameter is going to be subjected to the pressure area. So that I am going to be taking Fp by area is equal to pi by 4 d square. So as we know, the pressure force I am going to be calculating here, that's going to be the pressure force which is applied by the fluid, that is equal to pi by 4 p into d square I am going to be writing. So this is the force acted by the fluid, and similarly the material of the vessel, it is also develop the sustained resistance to opposing the pressure forces. That I am going to be taking, the sigma 2 is equal to, that is going to be the resistance force Fr by area I am going to be taking. So now can you tell me Fr is going to be, we need to be calculate, so that, and the area is going to be which area it is going to be suffering. Can you see? This is going to be the area it is suffering. It means that the circumferential of the vessel is subjected to the shear forces. So that I am going to be writing Fr is equal to pi d is the circumferential area, and it has a thickness also, that I am going to be writing the T over here. So then finally the resistance force developed inside the material, that is equal to pi into sigma 2 into dt I am going to be considering here. So now we can see the limiting forces are going to be developing here. The limiting forces are, so that's going to be, I am taking the equation 1 and the equation 2. So that I am going to be taking 1 is equal to the 2. That means the developed force because of the pressure is equal to the resistance force. So that I am going to be taking, here is the pi by 4 p d square, right? So that is equal to pi sigma 2 dt I am going to be considering. So then what happened, pi will going to be cancelled and the d will going to be cancelled here. So that I am going to be taking here, the sigma 2 is equal to, this is going to be the PD divided by 4 into T I am going to be taking. So this is going to be the stresses are going to be developing inside the material, right? So that is equal to, so that I am going to be writing here, the sigma 2 is equal to PD by 4T. Clear? And similarly, when the circumferential is there, then what will happen? It is going to be the 2T we are going to be getting. The relationship between your circumferential stress and the longitudinal stress is equal to, the sigma 1 is going to be your circumferential stress, PD by 2T we are getting. Right? From this one, I am going to be writing the sigma 1 is equal to 2 into sigma 2. So that means the circumferential stress is going to be the twice the longitudinal stress it's going to be assuming here. So this is the way we are going to be developing the mathematical model to understand the response of the pressure vessels when the longitudinal force is going to be acting on that system. Still, if you feel any confusion, please put in the comment section so that I can reach you out. Thank you.